Welcome to this week's MTD podcast. Today, I'm really excited to discuss the new desktop CNC milling machine. I'm Giovanni Albanese, hosting today's show, a passionate engineer and a proud member of the MTD team. And I have the pleasure to be joined by Zach Dunham, remotely from New York. Zach's the Director of Marketing at Bantum Tools and is helping celebrate the advances in desktop fabrication and high-precision milling. He has been instrumental in helping identify key attributes of CNC milling to include the newest Bantum Tools machine, the Bantum Tools desktop CNC milling machine. In addition to his marketing job, Zach is also part of the team that fine-tunes custom toolpaths, feeds, speeds, and helps walk customers through the CNC process. Welcome, Zach. You certainly wear many hats.
Thanks. Thanks so much for having me.
No, thank you for joining us, Zach. It's brilliant that you can join us remotely from New York for this MTD podcast. Do you see much of our content in America?
Yeah, I do, and I actually just brushed up on two recent episodes. One on SLA printing, and another on work holding. So, yeah, I'm excited to be on and joining you.
No, fantastic. Now, Zach, firstly, can we start really? Can you tell our audience and our listeners a little bit about you and about Bantam Tools?
Yeah, sure. I'll start with Bantum Tools. So at Bantum Tools, we make desktop CNC milling machines. We focus on making CNC milling machines that have precision and reliability and are really in sort of the realm of affordability. So we've been around for about 7 years. Our first product was a PCB milling machine, which was really specialized at milling fine detail circuit boards. Um, Single-sided or double-sided circuit boards. And that market, it's interesting. That market has kind of moved on a little bit as China has some really enticing offerings of quick turn PCB milling. So if you're an electrical engineer, you can very easily purchase a small run of boards that make it pretty cost effective. But that's where the company's roots are. And we had been producing this really tiny 17-pound desktop CNC with a 26,000 RPM spindle, and a lot of our community really loved it. And it was the tool that they were really getting started with CNC. But the capabilities for aluminum and harder materials is really where that machine fell short. So our new flagship product, as you mentioned at the top of the show, is the Bantam Tools desktop CNC milling machine, which is really targeting making aluminum parts quickly and easily. And so one part of that is the hardware, which we can discuss, and the other piece of that is the software. Yeah, for me personally, I mean, I'm sort of I don't know, kind of pseudo airsats type of engineering person. My background is really in audio, and I briefly dabbled in acoustics, but I've been in the hardware world now for 6 or 7 years. First on some of my own projects, producing like a little single station radio that I run as a side business and sort of side hustle, and then working at Kickstarter, the crowdfunding platform, where I sort of shepherded hundreds of products to launch, and with a focus in digital fabrication, which is kind of how I ended up at Bantam Tools. Yeah, working on this machine.
Great story, absolutely superb story. How have you found the market in America at the minute with everything that's going on?
Yeah. It's tricky, especially and especially painful for someone launching a hardware product where, this industry, revolves around trade shows and being in person to show off these tools. And, customers want to speak with somebody, they want to see it in action. And so to be honest, we had quite a big spike in sales when COVID first hit. Our previous product, the Bantam Tools desktop PCB milling machine, which is no longer in production, we just blew through sales. And I think that a lot of other companies in the digital fabrication space, certainly in the desktop space, saw this as well, because people are working at home. People are needing to find other ways to finish projects and to augment their capabilities, in their basements and closets and, other remote types of production. But it hasn't been without its growing pains for us, because we're also in the midst of production. So how do you take a small team? We as Bantum Tools, we produce the machine in house. About 90%, I would say, of the actual manufacturing happens within the confines of our HQ. And so COVID has, I would say, mostly impacted our business, just in terms of structuring. How do we keep people safe? How do we keep people healthy? And how do we stay on target? Which has been tricky,
It's been been challenging, Zach.
super challenging.
I think that we've all had to diversify and adapt to these unprecedented times. I think in the UK, what we've seen is engineering companies that have invested in the latest technologies, and automation, for example,
Hmm.
have managed to seem to get through this, w- w- with more ease, I would say. But even for companies that are looking to sell equipment, we've had to adapt and diversify in the way in which we market products and put things to market. We've started to try and do a lot more live events, Zach. So people, like you say, they can't be person to person, but they can actually look at the products and ask the personnel questions remotely,
Yeah.
which seems to be working quite well at the minute.
Yeah, I mean, I can totally relate to that. We did our product launch, and I had actually, personally had a little bit of a scare. I thought that I maybe had COVID, and I was still in quarantine when we hit our product launch. So I co-hosted our launch event, from our spare bedroom in my house, and we did all these things where, we had spent months recording videos of the machine in action, machining aluminum, how the probing sequences work, getting customer testimonials. And so what would have been an in-person live event, ended up being this sort of show and tell, and, the hit list of the greatest videos that we were able to capture in the first few months of the product existing. And that was our launch event. And yeah, I think you're absolutely right. That's what that's where everything is shifting to. How do you host regular live streams? How do you have a podcast? So yeah, yay
Yeah, no.
digital
Well,
marketing.
it's definitely proving to be the way. For people and listeners that are listening to this podcast, check out the desktop CNC on YouTube. There's lots of brilliant videos on there that you can watch, so you get an idea of what we're talking about. Now, Zach, can you tell our audience about the desktop CNC? Why did it come to fruition? What markets are you looking to service with
Yep.
this product? And please, Zach, keep the price out of it. I want it's completely blown me away. So I want to kind of tell people how much it costs at the end of this podcast, if that's okay.
Sure, sure. So, yeah, we'll just do a sort of rundown on what this machine is. Again, its primary goal is to make machining aluminum parts fast and easy. And so it's a 3-axis CNC milling machine. It weighs about 80 pounds. It ships fully enclosed. Everything that I'm going to say now is just part of the standard package. So it ships fully enclosed. It's shipped standard with a T-slot bed that's got a simple bracket and toe clamp fixturing setup. It's got an ER11 collet system, so it can support up to 1/4 inch tooling. It's sort of at the heart of the machine is a 28,000 RPM spindle. So really leveraging more of a sort of the high speed machining characteristics that we're seeing become more and more popular. It's got a conductive bed, which is used to automatically set the tool length offsets, and it's also used to do a series of probing routines. So you can, just by standard with the control software that we make, put in a block of aluminum billet, jog the tool over the top left corner and hit start, and it will pop on down, locate the material within the machine, locate the height of your material, and start configuring a bunch of these offsets. Again, removing some of these barriers of entry. In terms of machining performance, I would say that Again, largely your listenership is more in the industrial space. So as I'm describing this thing, they'll probably think, what, that sounds pretty light duty, 80 pounds. How is that going to be rigid enough? But we've really engineered this machine to be the like one of the most, if not the most rigid desktop CNC milling machine that exists on the market. So the entire thing is made out of a 5/8 solid 5/8 inch aluminum structure. And we're, under the right setup, we're getting about zero point 0.7 cubic inches of aluminum material removal rate, which is, somewhere on the order of 60 to 70 times faster than what we were seeing with our PCB milling machine. And I would say somewhere in the order of 30 to 40 times faster than the other desktop machines that currently exist on the market at this price point. So, yeah, it's sort of a quick rundown on the machine. The build volume, or I'd say the bed size, is 7 inches by 9 inches by 3.5 inches. So yeah, the most restricting piece is in the Z. But if you're doing kind of like plate work, or making if you're a product designer and you're making aluminum prototypes, we actually did a lot of research on the average part size that's getting requested from a lot of job shops, and sort of tried to optimize our build volume for that. Um, what
Yeah,
else? What else am I missing?
yeah, no, I think that's brilliant. I mean, I can't recall seeing anything remotely similar like your desktop CNC milling machines in the UK. I would guess that there is a massive market for them in the UK, especially for kind of colleges and educational sectors. When I did my apprentice, well, I wish I had one of them when I did my apprenticeship, Zach, for sure.
Yeah, I mean, me too. Let me touch on that for a second. I would say that any owner of a company or product marketer is going to say, like, this is the target market for this machine, and we certainly have that too. But it's that we're just about to start shipping, and so we're really excited to see who ends up becoming the primary user for this. But it's designed with I'd say people who prototype, so product designers, small engineering firms, people who want to do small prototype runs and keep them in house, where they can learn something and save time and save money by keeping some of that prototyping in house. The other piece of this is the education sector. So a lot of the, I would say, quote unquote, hobbyist machines that are used in the classroom setting have they can go down two kind of branches. On the one hand, they could be smaller machines that aren't really as capable, and so don't give students a real clear understanding of, like, what are the limitations of speeds and feeds. Well, you're not actually getting them because the machine isn't powerful enough to even mill aluminum, right? Like, that's one limitation with the sort of teaching machines that exist. And the other is that they're huge industrial machines that are from 20 or 30 years ago, and the workflows and some of the software is just a bit antiquated. And they're expensive and they're difficult to maintain. So with the education sector, we're trying to create something that's safe, that's approachable, that's integrated with modern machining workflows, and that gives students an understanding of speeds and feeds, probing, CAD, CAM workflows. It's not going to be the machine that, if they want to be a trained job shop CNC machinist, that they're going to use for their entire career, but it's going to be that thing that gives them that initial spark of excitement that we've all had when we've made our first part.
Now, I think that brings me on to really my next question, Zach. Can you explain the programming side of the product and the different options that you have available, and how that can really benefit potential students? And it's not only for students, is it, Zach? I mean, I've
Yeah,
seen one of your case studies where someone was making the bevels of watches with your product.
yeah.
It does lend itself to actual producers as well as the educational sector, for sure.
Yeah. So software. The programming of the machine. So the way that the software works that we in-house create, it's control software, right? So it is the software interface that you're going to use to home the machine, to probe a part, to load a file. The biggest piece is that we create a real-time preview of the part. So you load your G code file, you select the tool diameter that you're going to use to mill that first or second or third operation, and it generates a preview. Look, here's your stock. Here's what's going to be left over after you perform that operation, and that's happening in real time as well while you're milling. Um, so G code support is obviously standard with this machine. The other kind of secret feature of the control software is that it does have an internally generated CAM for 2D or 2.5D projects. So you can take a vector file, an SVG, a scalable vector file, that you design in, say, Illustrator. This could be, you could think of this as, you know, MTD podcast, serial number one, or if you wanted to do an engraving on something, or it could be
Yeah.
a series of, circular patterns for a hole cutout. You drop that into the software and you have the option to choose, cutout, internal, external, or engraving. And you can select the tools, and then there's an accompanying tool library where you can set speeds and feeds. So if you're a new user, if you're a designer and you say, hey, I don't want to be bogged down with a CAD CAM workflow, I want something that's just simplified, we have that sort of generated internally within the software. But a lot of our power users, and certainly like the gentleman that you mentioned who's making watch cases, his name is Ian Schoen. It's a wonderful product designer. He also makes pens. He's going to use Fusion 360 or some other CAM engine. And so with that, we have post processors from the softwares. You'll post your file, load it in, and then you're off to the races with your preview and your probing. The probing, I would say, that is one of the sort of things that sets this machine apart from the other machines in this class. That the fact that you can very quickly and easily probe apart. You can define offsets from single axis probing. If you're familiar with like the Haas workflow of all of their probing routines of probing a bore or probing a boss or probing the outer rectangular corner, we currently have about 5 different routines, and that's an area of the software that's going to continue growing as well.
Yeah, I think the probing feature is a massive benefit really for kind of setting the datums for sure, without a shadow of a doubt. And I like the fact that you can integrate Fusion 360. Now, what really fascinates me, Zach, is a 28,000 RPM spindle. Now that is fast,
It's
for
fast.
engraving operations and probing operations to get decent surface finish, and that is remarkably fast.
It's fun what you can do with all that speed. The really neat thing is, there's a wonderful company that makes really nice CNC machines, Datron, and they also make tooling. They make some really nice high balanced tooling for high RPM speeds. And we can't get, I think their spindles are in the 34,000 to 40,000 RPM range, and we're nowhere near that. But it does open us up to using some of this other tooling that the pros are using. And so yeah, we've been blown away with some of the finishes that you've been able to get with that RPM range. And then I think for the obvious thing of, if you're doing lots of micro machining, micro milling, that small tooling, that high RPM spindle is really comes in handy. So
The ER11 collets and the tool holders.
yes.
What tool holders are you using, Zach?
So I think this is the piece that some of your industrial listeners are probably gonna roll their eyes at and maybe be a little bit grumpy about. So this is a fully sort of manual tool change setup, right? You're gonna take a pair of wrenches, you're gonna crack that collet nut, and the tool itself is going to come out of the collet, and you'll put just the bare tool itself right back into the collet. So we're not supporting. I believe you can get like an additional tool holder that would fit into that ER11 system, but it would use up more of your Z work volume. So that's why we just
Yeah,
go with the bare tool itself.
it makes perfect sense. I mean, I can remember again going back to my apprenticeship when I was using the bridge mills, and it was a
Hmm.
similar kind of setup. But
Yeah.
what kind of tolerances can you expect to achieve?
Um, so I think I would say also goes back to the, you know, who's, what's the saying? It's not the tool, it's the craftsman. I think with our market, we're going to see a lot of sort of give and take on the tolerances, just on some of the newcomers that will be camming out a part that won't really be done properly. But in terms of repeatability of the machine, plus or minus a thou.
Wow.
The lead screw accuracy, I would say, is something to consider too, which is that's one of the things that we're just limited by. So it's a lead screw, it's not a ball screw setup, and so that's closer to 4 or 5 thou, I think, if I recall correctly, over about 9 inches. So again, you know if you're doing really large, or if you're maxing out the work file, excuse me, if you're maxing out the work volume in the Y, and you're looking for really tight tolerances, um, this probably isn't the machine for you. But again, in this kind of product designer education space, that type of accuracy and tolerance is seems to be plenty in our experience.
It's completely application specific, isn't it, Zach? It's
Yeah,
dependent
that
on
too.
what you're making. It depends on the parts that you're making, and if you're an hobbyist, if it doesn't, you making parts from that machine, that it is for that. The part. Sorry, Zach. The parts you're making, um, may not need them kind of tight tolerances.
Right.
And it's perfect for making any part. I mean, again, you could get a machine that can, you know, microns repeatability and
Sure.
tolerances and old surface finishes, but then obviously that is not the product for. You won't buy that machine for the products that you're making on your desktop CNC, really.
Exactly. Exactly. Yeah. Um, yeah. It's totally application specific, and I would say that you know we should probably just talk more about this. Like the pinch that we have in introducing a product in this space, because there's a vacuum in this space. There's sort of no man's land. You've got the really cheap, sub $1,000 CNCs that are you can find a kit on Alibaba, or you can find a reseller that's going to sell you a kit that you're going to put together. And some of those are like engraving machines at best, right? They're not, you're not going to do any milling with them. Maybe you could cut a little wood. Um, and then at the other end of the spectrum is this sort of $10,000 range of a tool. Tormach is a U.S. producer of these types of machines, where you're getting into sort of light industrial, and we're squarely in the middle. So the interesting pinch, I would say, that I'll be the first to call out, is we get the hobbyists saying, why, I wish it were $500, I wish it were $1,000, and we get the industrial folks saying, well, why can't it do this, this, and this? And I think that's to your point. We'll reveal the price soon, but
Yeah.
it's
Well, for
because of the
me,
price.
for me again, Zach. I mean, I can see massive potential for this product in the UK. I've not seen anything like it, and I think from an educational perspective, and I use the example of my engineering college, they would certainly benefit from your products, and the reason being is that I strongly believe that the best place to start is on a conventional machine. However, you need to then progress to CNC,
Hmm.
and learn how to program a CNC. And then you once you've learnt on the conventional, you've got a better understanding of being able to program and to kind of figure out the feeds and speeds. But at the college, they've only got two CNC machines. So you imagine all them students having to wait or just watch.
Yeah.
Um, but with these products, that you mentioned the envelope of the product, the footprint, if you like, they could be in the classroom. There
Oh,
could be
yeah.
several of them. People could be learning simultaneously on them and getting all of the learning that they require for when they leave their universities and colleges to go into placement with a real good understanding of how to program a free axis milling machine. And I think that's fantastic in my opinion. And not only that, you've got examples and case studies of people actually producing parts on there, Zach.
Yeah, yeah, and some really fun ones. Yeah, I mean, like you mentioned, this guy Ian Schoen, he's using it to produce watch cases. He also makes a series of pens. He's got several Swiss lathes in his shop, but he does some customizations, and he'll engrave on the round surface of the pen. And this is a a clever cam setup, but it's very easy to do with the built-in probing to find that top center point of the round surface and start engraving on the round using this machine. So he's employing it in that kind of way too. And I would say the kind of approach that we're excited about learning more about as this machine gets out into the wild and has years under its belt, is how are job shops going to use a small desktop CNC? That's what I'd be really curious to learn from your listenership is, the type of user who doesn't want to take, cycle time from their big, VMC to produce a small jig or a small fixture. How would they think about using a machine like this? Whether it's a soft jaw out of aluminum or something quick out of Delrin. How would they employ a machine like this or several machines like this to take care of some of those tasks in the shop? And that's something that we're super excited to see more of.
Yeah, well, I think that's a really, really good point, really, Zach. And I think that really it's a good point to kind of really kind of start closing up the show on, because I
Yeah.
think that you've hit the nail on the head there. If you've got an expensive CNC machine that's costing you, between 50 and £100 an hour, um, effectively, whilst that machine is running, you could have your desktop CNC next to the machine, effectively making the jigs or fixtures for your next part,
Hmm. Hmm.
or the soft jaws like you mentioned. Perfect, absolutely perfect. And also, again, you know, bringing apprentices into organisations, there's no better way to start on a product such as this, in my opinion.
Yeah. Yeah. You sit somebody down for a couple hours in front of a machine like this, and you can know nothing about speeds and feeds and mills, and you're going to learn so much in such a short amount of time.
uh, Zach, just a few questions.
Yeah. Shoot.
Do you have skill issues in America? Is it easy to get the best young talent into engineering?
I think that, you know, I think that the story hasn't been told in the right way for, younger generations of how exciting a career in manufacturing could be. I think that we're still uh yeah, we're still challenged by people seeking different types of careers, but really they don't know what the opportunities may be in the manufacturing sector or what those jobs might look like. I think that's it's certainly something that we're trying to address with this machine and through partnerships with universities and this has been the narrative in the U.S. and I would say in the U.K. as well, through the STEAM initiatives that have been going on for the last 15 years. Um, but yeah, I would say that our primary issue is getting people excited about this. But there's still a huge shortage of even CNC operators. I could say that currently we're hiring for 2 CNC operator roles at Bantum Tools, and it's not always easy to fill.
Wow. It's just crazy, isn't it? Zach, it really is. Now, Zach, before we reveal the price, would it be okay sometime in the future that the MTD put this to the test, put your product to the test? It'd
Oh,
be an absolute pleasure to film it and put it to the test at some point, hopefully.
I would love that. Yes, we should. Let's stay in touch about that, and we can make that happen.
So, Zach, that's brilliant. How much does this cost? I mean, this is just completely just. I'm flabbergasted, and I'd love our listeners to kind of just know why.
Yeah, sure. So the Bantam Tools desktop CNC milling machine is currently on sale for $35.99, um, and that yeah $3,599, and the MSRP price is $3,999. So we're currently in a discount on the machine as we're in this sort of launch phase. But our goal all along was to make this affordable. That's Bantam Tools sort of motto is, you know, professional reliability and precision at an affordable price. We don't think that these tools need to cost an arm and a leg to certainly not to get started. So
It's absolutely superb. That price is just phenomenal. I mean, just out of curiosity, Zach, how many have you sold in the US so far?
we are in the hundreds, I will say. We've been live now for 60 days, and yeah, we're in the hundreds.
In 60 days, it's just Just brilliant. Well, Zach, it's been an absolute pleasure for you to join us on the MTD podcast. And I hope you stay safe in America, and we really hope to catch up with you soon.
Likewise. Thanks so much for having us.
Thanks, Zach. So if you've enjoyed the MTD podcast and you've liked what Zach says, or if you have any questions, please let us know and we will address them. Thanks for listening to the MTD podcast. Until next time, stay tuned.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.